Hello. First, I would like to thank the organization for selecting our work for a fast-forward presentation. My name is Fátima, and I'm going to present the work performed at our lab in which we estimated the true positive rates of CNV detection by whole exome sequencing with depth-based analysis. Currently, it is a common practice in diagnostics laboratories to use whole exome sequencing data not only to detect single nucleotide variants and small indels, but also to detect copy number variants using a read-depth-based approach. The aim of this work was to evaluate the efficacy of detecting CNVs through read-depth-based analysis in our routine diagnosis. From almost 4,500 samples, we selected 434 CNVs that we consider likely to contribute to the patient's phenotype. All of these CNVs were confirmed by an ortholog method that was either a qPCR or an MLPA. All of our samples were sequenced in an Illumina platform, but we did use two different capture kits. We either used the Agilent SureSelect kit or the Twist Human Core. As you can see in this scheme, we have a significantly larger number of samples that were captured using the Agilent kit, almost 3 times more. And for this kit, we had 31% of true positive CNVs and 69% of false positive CNVs. As for the Twist Human Core, we had 59% of true positives and 41% of false positives CNVs. Looking at these numbers with more detail, we can see that for the true positive CNVs, the vast majority of those occurred in deletions for both kits. As for the false positives, we can see that there isn't really a big difference between both kits for both deletions or duplications. If we look at this, but dividing the CNVs by size of 3 or less exons or 4 or more exons, we can see that the vast majority of the true positive CNVs occurred in larger CNVs with 4 or more exons. On the other hand, for the false positive CNVs, we can see that the vast majority of those occurred in smaller CNVs with 3 or less exons. In conclusion, we can observe in our own experience the already well-known intrinsic limitations of this approach. The false positive rates remain high. We can also conclude that the accumulated internal experience and improvements in capture and sequencing contribute to the increase of true positive rates. This kind of approach always requires confirmation by another methodology. And finally, read-depth-based CNV detections from NGS data is in a routine bioinformatics pipeline a cost-effective add-on for diagnostics labs. Thank you.